Let's have a look at gears. All right, now gears are just rotating discs that are attached to shafts. They are connected in some way. A lot of gears are just connected directly. They mesh together with teeth, but you can also connect gears together with a chain or with a belt. The usual function of that is to change angular speed in some way. All right, I have an example of how to work through a gear train or a set of gears. So let's have a look at how you could figure out the angular speed of gear D if you know the angular speed of gear A. So I see what page this is on. I think this is on page 509. So what I have up here is a 3D sketch of the gears. So A meshes with B, B and C are on the same shaft, and then C meshes with D. All right, and let's first look at how these things are going to turn. The way you kind of work your way from one gear to another is you look at the rim speed or rim velocity, which is the velocity of a point on the rim of the wheel. And that's found by using V is R times the angular speed, omega. So if we follow this set of gears through, this one's rotating clockwise, and it will mesh with gear B. Now gear A is moving down. It's going to mesh at this point, I should say, on gear A is moving down. So that'll mesh with gear B and move that part of gear B down, which will make gear B turn counterclockwise. Now B and C are on the same shaft, so C will turn counterclockwise also. It'll mesh then with D right there. And from this sketch here, that point of gear C will be moving up, so that will move this point of gear D up, which will turn it clockwise again. Okay. So D is rotating clockwise. Now the two things that I look at with gears is their angular speed, omega, and the velocity on the rim, which is the radius times the angular speed. That gets you the velocity of a point on the rim of the gear. So if I know that omega A is 60 radians per second, I can work through that set of gears and find the velocity of gear D. I like to set up a table to do this, so I've got columns for the gears and rows for omega and the velocity of the rim. So we'll start with omega for A at 60 radians per second. Now we're given the radius of A is 50 millimeters, that's 0.05 meters. So I can take that times the 60 and get 3 meters per second. That's a velocity of the or speed of a point on the rim of A. Now that's meshing directly with B. So A will have that speed on the rim of 3 meters per second, but so will B because it meshes with A. So I can take that 3 meters per second and just move it over to the rim velocity column for B. Now I know the speed of the rim of B and I know its radius, so I can just take that V is R omega formula, or omega R, I guess we might write that, and I can divide both sides by R, and I can get then omega is V over R. Okay. So I can use that, and using that formula I can find the angular speed of B. It's the velocity, the rim speed, 3 meters per second, divided by the radius of B, 0.08 meters, so that's 37.5 radians per second. Now that's B. Now B and C are on the same shaft, so what I can do, I can take that omega and use it for C also. Let's put it right there. Now C is going to mesh with D on the rim, so I want the rim speed of C, so that'll be omega times R, 37.5 radians per second times the radius of C, which is 0.04 meters, so that's 1.5 meters per second. That's the rim speed of C, which meshes with D. So the rim speed of D is also 1.5 meters per second. And then to find the angular speed of D, I just divide the 1.5 meters per second by the radius of D, 0.1 meters, and I'll get 15 radians per second. So by connecting these gears with the different radii, you can take the angular speed of A at 60 radians per second and take it down to 15 radians per second for D. Now I'll get you one homework problem for this, and this homework problem will be due next week on Friday. It's problem 273. It's on page 16B. It'll be due next Friday. Now this is a lawn spreader. Looks something like that. So what we're going to do is take the rotation of the wheel as we push it and work that through this gearbox right there and take that up to the spreader vane. The spreader vane will then throw the fertilizer out in both directions. And so what we're going to want to do, if we know the velocity of the lawn spreader, 1.6 meters per second, we're going to want to work our way through the gears and then find the velocity of the outer edge of the spreader vane right there, because that will be the velocity of the fertilizer as it's being thrown out. Now we're going to throw the fertilizer both directions, so based on that we want to find the width of the swath, how widely the fertilizer is dispersed. Okay, so that's the goal here. So you know you've got the rim speed of the wheel, which is the velocity at which you're pushing the fertilizer spreader, 1.6 meters per second. So that would be the rim speed of A. You just want to build yourself a chart like we just did. Work your way from B to C and then up to D. You're given the diameters of all these things. And what your goal here is to find the rim speed of D. Once you've got that, you can just assume that rim speed here on the spreader vane is transferred directly to the fertilizer. So the fertilizer will have a velocity equal to the rim speed of the vane. And then you can just look at the path of the fertilizer as it falls, and from that get the swath width. You're given the height of the spreader vane is 30 centimeters above the ground. Okay, so that'll be due next Friday. And that's problem 273, and that's on page 16B.